Okay, now it's time for everybody's favorite part, going through these. Oh, I still got some coffee left. Hold on. Good. All right. Anyway, so we are ready to calculate. What we're ready to calculate now is, let's go through the mini quiz real quick and make sure that I've covered everything, and we can take some notes down here on the on our. Let me turn on the ladybug here. She's plugged in. Sorry, I should have all this ready before we start. Let me move my big old coffee mug here. There we go. All right, so now let's take a look at this. All right, so let's just open up mini quiz number 5 here and go through it. It's closes September 14th, a week from today when I'm recording this, at 11:59. That's good. Test allows multiple attempts. You get 3 attempts. Of course, your best attempt is the one that counts. Okay, so first, little multiple choice action, following the slides and looking at watching some of the videos. Simple multiple choice stuff that you can do on your own just by watching the few things we did there. Okay, so all right, now here's one. Now question 5. There's only 14 questions. We've already done the first 4. I mean, we're kind of flying through this. So, according to Steve Kroft, the 60 Minutes reporter, a wingsuit allows you to fall 5 times slower than gravity, okay? Which is a very non-mathy way of saying 1/5 the acceleration of gravity, okay? So that's your rate of descent. In other words, you are gaining 1/5. Now, gravity is what? If gravity's acceleration is 9.8 meters per second squared, what is 1/5 of that? 1/5 of in math. When you hear the phrase of, what does that mean? Multiply? Maybe. No, I know for a fact it means multiply. But if you're taking 1/5, how about divide by 5? Oh, that could work too. All right, so we don't need to work all that out. So now, in the 60, they also said the wingsuit, you fall 1 foot for every 2 feet you go acrosswise. So if you jump from 6,000 feet, how many feet can you soar in the x direction? In other words, crosswise. If you're going to fall, if you're going to go down 6,000, See, I'm not going to work these out. You think about it, and you've got the choice of your answers are there. Okay. In the 60, the Birdman reached speeds of, how fast is 140 miles? So I'll start with question 7, though. One more time. So once again, on question 7, let's see, this is notes for mini quiz 5. Okay, notes for mini quiz 5. On number 7, we had, 140 miles per hour? Now remember, we've got our little thing where we take the 1,609 meters per 1 mile. That gets rid of that mile there. The per is just the divide sign. Times 1 hour. So we need to get rid of that hour, so we'll put it upstairs. Times 3,600 seconds. And actually, the 1,609 divided by 3,600 gives us our magic number in this class of 0.447 is our conversion. This is how we go from miles per hour. We multiply by 0.447, and that'll equal our meters per second. Okay, that's our little conversion. That's our little secret. Okay, let's assume one of the Birdmen has a mass of 80 kilograms and he's soaring at 144 miles. What's his kinetic energy at that moment? Okay, if we're talking kinetic energy, you must convert that 140 miles per hour into meters per second first before you do this problem. And we know that on problem 8, kinetic energy is equal to 1/2 mv squared. For those of you that are new to the math thing, that would mean 0.5 times his kilograms times his meters per second that he had squared. Okay, that's the way you'd put it. That's the way I do it on my calculator. All right, question 9. In the Science of Hockey video, okay, they talk about the flex or the whippiness of a stick. All right, so the fastest slap shot recorded was 106 106.2 miles per hour. I think that's what they came up, or was it 107? Whatever. Compute with 106.2 miles per hour. If the puck has a mass of 0.175 kilograms, what is the kinetic energy of that puck? Don't forget to convert, once again, miles per hour to meters per second. And again, for question number 10, it's 1/2 mv squared. Okay? And then, by the way, Gary Connery, who jumped into those boxes in the thing, we're going to assume that he slowed down, like we said in that one slide, that he could slow down to 60 miles per hour. By the way, 2 years later, he passed. I didn't know that. And they also listed all the movies that he's been in, all the Batman and James Bond movies that he's been in. He was doing wingsuit jumping in the Alps and he died. So I mean that just goes to show that the best of the best, they're going to buy the farm. I mean it just looks like a zero-sum game to me. Okay, let's assume he has a mass of 75. His kinetic energy then would have been 26,975 joules at that moment, okay, if he's going 60 miles an hour. And let's assume he traveled 18. I kind of calculated that based on very rough estimates of the time that it took. I saw those boxes crumple in a line. I watched another video where it showed the boxes crumpling in a line. And it took about 1.6 seconds for that. Is what I got, which was a very imprecise way of doing it. And so I was able to calculate the distance. And so I guessed about 18 meters. What was the stopping force? So on question 11, what we're saying, so 9 and 10 are easy peasy. But 11, once again, we calculated his kinetic energy, which is equal to the force times the distance that brought him to a stop. Now this is the force, this is the stopping force. This is the force going in the negative direction. If you're in my Physics 210 class, we'd spend a lot of time talking about negative and positive direction of the forces. Okay, so, but we're trying to, I gave you the distance, we're trying to calculate the force. How do you do that? You take his kinetic energy divided by the distance, and that should equal the force. They face planted himself. All right, 2 problems left. Felix Gumbauer left from 130,000 feet out of a jet airplane and flew in those for 22 miles across the English Channel. First question, how many meters is 22 miles? Google it if you need to. All right, and then he flew for 10 minutes. How many seconds are in 10 minutes? All right. And then last but not least, using this one, using your answers from 11 and, or actually 12 and 13, I should have said. Okay, so I got to change question 14 to say 12 and 13. Okay, now from 14, then from how was Baumgartner's speed in meters per second? Now convert that to miles per hour. Okay. And you could have done it miles per hour. You could say, well, he went 10 miles divided by 10 minutes in a mile, so divided by 1/6 of a mile. So, you know, it's going pretty quick. All right? I need to go and change these numbers. I need to change this to a 12 and 13 and this to 14. Okay? So you should be fine. No, not scary.